Hello again, you sick, twisted weather freaks, and welcome to another special edition of This Week in Weather. I'm your host and meteorologist, DT from Weather Risk, your captain of chaos and colonel of confusion, your commander of catastrophe. Let's talk about this week in weather for this Friday, September 20th into Saturday, September 21. A lot to talk about here. One of the issues coming up is, of course, what happened to the hurricane season. Probably going to do a special thing about that next week or maybe in the first week of October. We already get a little burst of hurricane activity coming up here, I think. So I don't know if the season will be a complete bust, but certainly it has not seen anything like the super activity we were supposed to have seen. And we'll get into the reasons for that later on. But now that we're at the equinox, we'll start doing the This Week in Weather forecasts every week here. So let's get right into it. This is the Weather Risk Grains Twitter page if you want to follow me there, mostly for my commodity clients. This here is the Weather Risk Facebook page, as you can see. And then let's get into the data here. So this is not October, excuse me, didn't change the date here. This is September 18. Yeah, and you can see a couple of factors here. Area A is this pool of extremely warm sea surface temperature anomalies. Clearly the warmest that we've seen on the planet right now. In fact, let me call a marker here so you can see what I'm talking about. Here we go. So this is the warmest sea surface temperature anomalies on the whole planet. If you look at that white color inside the red here, that's around 5-6 degrees centigrade above normal. From the coast of, really off the coast of northern China, Manchuria, Japan, Korea, out to the northern Pacific, south of the eastern tip, the western tip of the Aleutian Islands. So very, very impressive. This is a huge feature. And then we also have this pool of sort of warm water off the west coast of North America. Now, normally when you look at this, you say, okay, well, that's a positive PDO, going to produce a PNA pattern. But the thing is, relative to this pool of water here, all of this is relatively cool. So we are in a negative PDO because of it. In order for this to change in the Pacific, we have to get this pool to, go away, wash out. And so far, it's not. It's been there for weeks. I mean, I can show you the sea surface temperature maps from March and April. It was there. It's just not going away. Area B, this is the developing La Nina right here, very nicely showing up here. And then that's area C, as we talked about, the west coast. And then this area here between Africa and South America, that's the negative AAM. And that really doesn't have much of an impact for the North America pattern. It has some impact on the tropics, a little bit here. The cold water here is kind of weakening the cold water we're seeing in the tropical Atlantic. Things are cooling off there. And this is also going to have some implications for the drought in Brazil. But that's a different subject altogether. You can see just the latest values here from the CFF, from the ENSO region here. These are different ENSO regions. 1.2 is off of South America. There's 3, ENSO 3, 4. That's the big one that we look at. And then ENSO 4 almost out by New Guinea, Indonesia, and the Philippines. So there it is right along the equator. And you can see the values are going up and down here. But if you look at the general trend, you'll see here, you can see the general trend very nicely. This is region 3.4. Since July 1st, you can see the trend is clearly downward, right? And then the same thing now. ENSO 1.2, this is interesting. It's actually going up here a little bit, a little trend here. And one of the reasons for that is here. If you look at the actual anomalies, you'll see, this is the last 15 days. And again, this is from folks, this is from Alex over at Cyclonic Weather. You can see, look at the pockets of warm water right here that are mixing in. So this is not a very strong La Nina, it looks like. And the Atlantic, clearly the subtropical Atlantic is cooling off. This part of the Atlantic is cooling off. I mean, it usually does in mid and late September anyway, but we can clearly see it's dropping off here. And then this pool of extremely warm sea surface temperatures that we saw here, you can see how warm it has been. You can see it's clearly dropping. It's maintaining its intensity right here. This is, if anything, this is getting warmer, which is hard to believe. So, that's a real trend. And now if you look at the equatorial Pacific, now this is interesting here because you can see this is the equator right here, all right? Right along the equator. And this is looking down into the depth of the Pacific Ocean along the equator. Now this is off the coast of Peru, South America. And notice this pool of warm sea surface temperatures, 3 degrees centigrade, 2 degrees centigrade off the coast of Peru. And that's what we're seeing here. Say this is what we're seeing right here. This pockets of warm water. Now, The other difference is that we have this nice pool of fairly cold sea surface temperatures, -3, -4, about 150 meters down, 160 degrees west longitude. But this pool of cold water is not moving up to the surface. If this pool of cold water were to move in mass up to the surface, that would trigger a moderate or strong La Nina, but it's not doing that. I don't think it's going to. So that's something to watch out for, and you'll see. So we are seeing the trends like we talked about. It is going down at 3.4, 1.2 is going up. If you look at the latest projections here, now this is the latest CFS, and you can see, if we blow this up a little bit, let me move my marker right here so you can see a little bit. Okay, what I want to bring out here is that this is the 1 degree line centigrade, right? And you can see the dashed black line is the mean of all these different projections. And you can see it's actually around 0.8. It reaches its peak negative value, La Nina, at around in December. Now, this line here is January. Look what it's doing. It's already weakening in January. See how it's coming up? January, February, March. By March, it's gone completely. February, it's almost gone. So this, as long as it stays 0.8, 0.75, underneath, doesn't reach -1 degree centigrade, then we have a weak La Nina. That's what the European is showing as well. Okay, this was September 5, and again, now the black line here was the August projection, and it was against La Nina. The new one, the red line, is the September projection, but look, notice, again, the 1 degree line here, let me call up my marker. Oops, no, don't want to do that. Here we go, this marker here. Here we go. So this is your -1 right here. See it? Okay. And the thick red line is the mean of all the runs, and it's around -0.75. So it is colder than the August and July projections, but it's still a weak La Nina. And again, by January, it is weakening, and by March, it's over. And these are other projections, so you can see it. These are the American climate models in September, the CFS combined with the other models, and they all show the same thing. These are all North American different climate models, NCAR, the GEM, the GFDL, National Center of Atmospheric Research, NASA, GFDL, and here, and with the CFS. And the CFS is the thin gray line here, but notice only this blue line, which is the NASA GOES model, which is just crap, so I'm not going to ignore it. But the vast majority, and again, the dashed line is the ensemble mean. It reaches its peak between December and January, and clearly by January, these lines are coming up, February and March. So this is a short duration La Nina. And then if we look at the CFS, the thick blue line, we compare it to the European climate models, the European, the French, the British, the German, and the ensemble, super ensemble, you can clearly, again, the dashed black line is a little warmer than the CFS, and none of them get below, 0.75, not even close. And some of them are pretty weak. Some of them are pretty weak. So that's something to keep in mind. What this means is that, if we're looking into the winter, what you want to look for is a La Nina, which is a short duration and does not get very strong and actually weakens or falls apart in late winter or early spring. So those are the parameters I look at. And there's several winters like that. 2016-17, 95-96, 64-65, the winter of 22-23, and 1983-84. So there's a couple analogs out there. All right, let's take a look at a 200 millibar velocity potential anomalies. And the reason why we use this is because this gives us an idea of where the rainy patterns are going to be setting up, where the stormy pattern is going to be setting up. So, large-scale global weather patterns have areas of enhanced low pressure, high pressure ridges. When you have sinking air, which is here, okay, the air is descending from up high down to the surface, high pressure. The molecules are literally coming down to the surface, and you're getting more air molecules here. So this suppresses cloud development. Sinking air causes it to warm a little bit, and you can see we have no rain in this side of the pattern. Now, rising motion obviously is like a hurricane or a low pressure area. The clouds are going up, condense, you get your rain, and so on and so forth. Convergence at the surface, divergence aloft. So we can see this going around the globe at different time frames. So this is a nice chart which comes from weather models, and this shows us for the next 2 weeks. Now this says September 12th. It's not. It is September 18th. Let me change the date. And here we can see. So the dark orange and red colors represent sinking air, and the darker or the more red, the more stronger the sinking air. And that means suppression of low pressure and dry conditions. On the other hand, if you have green colors represent rising motion and increased chances of rain. So we can see this different areas around the globe here. One of the things we want to point out here is this is the Western Hemisphere. This is Brazil, and there's the Caribbean, Western Atlantic, and the North America. So all of this dark green stuff represents a new regime change in the Western Hemisphere. We've gone from this orange stuff to now this dark green stuff, which represents strong rising motion. Okay? And in the Pacific, we're getting a lot of suppression here, a lot of sinking motion here. So potentially some kind of ridge forming in the Central Pacific. And of course, if we can look this further out in time, and again, this is September 18th. I'm sorry, I forgot to change the dates. But you can see once we get to October 8th, we look kind of neutral here. We're not seeing much in the Western Hemisphere. Well, another way of looking at the same diagram here is to look at the next 2 weeks. So here's the European week 1 and then week 2. Notice the green areas in South America and the Caribbean and the Gulf of Mexico, the Western Atlantic Ocean for the next 7 days and then into week 2. So this would favor an increase in hurricane activity, but in the Western Atlantic and the Gulf of Mexico and the Caribbean and that area, in around Florida, Southeast states, that sort of thing. Okay. Also, this is very good news for the drought in South America, Brazil. It would indicate a much wetter pattern developing for that portion of the world as well. But that's just a sidebar. All right. Here in the U.S., you can see the temperatures have been amazingly warm in the Midwest last couple of days. We have this drought here, and remember, the rains we've been getting in central and eastern Virginia have not hit West Virginia or Ohio, southern Illinois, Indiana. They're getting really bad drought conditions here. Drought conditions 3 and 4 in Ohio and West Virginia. And you can see general drought conditions expanding because it has been so dry in August and September in the Midwest. Now, we haven't done that bad on the East Coast, the southeastern states, and New England. We've been getting these cold fronts and rain events and low pressure areas and remnants of tropical systems. But the Ohio Valley in particular has been very bad, the Tennessee Valley. Also look at Tennessee, some dark red areas popping up there. And you can see that the soil conditions are really drying out very rapidly here, especially east of the Rockies. Temperatures have run very warm, as you can see, last couple of days. This is Wednesday, this is Thursday, temperatures well above normal. Not so much on the East Coast. I'm talking mostly the Midwest and the Plain States. And this has been the pattern for the last week. All right, so we have this big upper low, a huge trough on the West Coast, an enormous block right here in Canada, as you can see, over the Great Lakes into southern Canada. And then we have this tropical energy, which was, I think, Francine, lingering over the southern states. So, as you know, that's produced this warmth. This block here in the Great Lakes and Midwest has produced these temperatures. Look, in mid-September, it's not normally 89 degrees in Des Moines or 88 degrees on Wednesday and Thursday this week. It's normally not 89 in Indianapolis or 90. Okay, it's pretty warm. Now, it's not July heat, but it's pretty warm. Okay. So what's going to happen here is, it gets interesting now. So let us call up the upper air map first, and we'll take a look at that and enlarge it a little bit. Okay. And let me call up a marker so you can see it. Okay, this should do it very nicely. I'm going to change the color of this to black, I think. There we go. Good. And we'll copy it. There we go. So here we go. There's an upper level low, like we mentioned, again on a slide here. There was the upper low in California. It moves over the weekend into the southwestern states. Meanwhile, we got another piece of energy coming out of Alaska, the northern branch. So this is your northern branch jet stream. This is the southern branch. See that? Okay, they're separate. You have a nice ridge over Texas into the Midwest, and there's a trough on the East Coast. And the other feature is this gargantuan block. I mean, if this was the middle of winter, wow, this would be a great pattern for the East Coast. But it's not, of course. Upper low off Newfoundland, Canada, gargantuan block right here. Now, these two features are going to get together in some capacity over the next several days. And what that does is that produces, this upper trough here is going to produce a surface cold front, and then this piece is going to catch up to it. So let me show you what that looks like on the surface map. There's the cold front coming through. There's the ocean storm in the Western Atlantic Ocean, which may develop tropical characteristics over the next couple of days. We'll see. And then Now here we go into next Monday to the next Tuesday, I should say, September 24. So these two features are getting together in this big trough. Look at the block here in Greenland in northeast Canada. Can you believe that? Nice ridge forming in northwest U.S. and southwest Canada. Okay, and now you can see, now that is the European, here's the GFS. It's a bit more broken apart, but the same idea. A low here, low, low, same thing, same general idea. And these features are going to get together in some capacity. Now, it's going to be tricky because there's also a tropical aspect to this thing. And let me show you what I mean. Here is the tropical feature that is on the satellite picture on this Friday afternoon. There's a nice cluster, a nice area of heavy storms here in the Gulf of Panama. And now this, many of the models are slowly drifting this over the next several days through the Yucatan, Northwest Caribbean, and then somewhere into the Gulf of Mexico where it begins to finally generate. Let me show you what I mean. This is the GFS, and this is some early on Friday morning. You can see the ensemble solution, a strong indication of some kind of significant tropical cyclone, probably a hurricane, in the Northwest Caribbean, Yucatan Channel, Central Gulf of Mexico on September 26th. This is the European, same sort of thing. Now the European is a little further west, but it's the same general idea. We don't know where it's going to be, but somewhere Northwest Caribbean, Yucatan, into the Central Gulf of Mexico. Now, as the cold front comes east, okay, we get a lot of rain here. Here's the European, finally bringing some rain into the Midwest for next Monday. There's the GFS Monday night, Tuesday. So the same general idea. The European is a little wetter. And then we have to worry about the interaction because, all right, let me show you what I mean. Bring this up. There we go. So this is the European model from midday here for day 6, valid September 26th, I should say. So, okay, so we have this southern low, and there's the tropical system. So are these two features going to merge into one big system and get pulled northward? Meanwhile, look at this titanic block from Manitoba, Canada, all the way up into Greenland. Absolutely off the charts. Massive block here. So, and then we have an upper low that forms in New England. Very complicated pattern. This is really complicated because this block is driving the whole thing. All right? And then we have this big energy here in the Gulf of Alaska and Western Canada. So this trough is forcing this block. So as long as this feature is here, this feature is here. All right? That's the European. The GFS is showing the same general idea. Perhaps a little better, I think, on the GFS. There's the tropical system coming north. All right? We have one piece of energy here. Let me blow this one up so you can see a little more. So we have one piece of energy here in Pacific Northwest, another upper low or piece of short wave in Kansas, Oklahoma, and there's the hurricane in the Gulf of Mexico. So these two features are going to merge and then pass underneath the block into this upper low. I mean, this is really complicated. There's all sorts of possibilities with this system. Now, the question is, where does it make landfall? So let me show you. All right, this was the European model from early Thursday morning. And you can see it's got a weak system in the Gulf, cold front moving through here, another system coming out of Montana and the Dakotas. But the midday GFS is much more bullish with the system. It makes a bigger hurricane that goes into Louisiana, Mississippi, Alabama, then it goes to southeastern states. The highs to the north, as you can see right here, blocking it. And rain gets into Virginia and the Carolinas, Kentucky, Tennessee. You know, this is one possibility. Of course, it's inland. It's much weaker. Now it's a gargantuan low pressure area. And if it gets absorbed in the upper low, which is what the European was showing this morning, then you have a giant eastern U.S. storm. It's not a hurricane anymore. It's a non-tropical intense low. So there's all sorts of complications. I do not know what solution here is correct. I don't know where the hurricane, if it forms, is going to go to the western Gulf, the central Gulf, the eastern Gulf of Mexico. Any one of those solutions is viable. We just don't know at this point. I think something's going to happen. We just don't know where or when it's going to happen. And that's going to depend on everything. Is it going to go into the western Gulf of Mexico, then into Texas? Is it going to do Louisiana, Mississippi? Is it going to do Florida? And then get more pulled up the coast and then maybe keep more tropical characteristics? I've seen the GFS, the European, show these solutions several times over the past 36 hours. It's something, but I don't know what it's going to be. And there's actually even behind that one as well in the first week of October, which may also do a Western Caribbean, Yucatan Channel, Gulf of Mexico thing. So You'll see, we'll play it by ear and see how it goes. But I don't have a solution on one or the other right now. So we'll probably do another video on this, I would think next Wednesday. And then, after the newsletter Sunday night, Monday, then we have a video next Wednesday, see how this is going to play out. All right, this is meteorologist DT from Weather Risk. I will see you over on the Weather Risk Grains Twitter page and then over on the website.